Your brain is a beautiful machine, finely tuned by millions of years of evolution to understand distances. You know how long it takes to walk to your car. You can visualize the distance across your city, or even the flight from New York to Tokyo. But if you try to truly comprehend the gaps between the stars, your brain doesn't just struggle. It crashes. We look up at the night sky and see a crowded canvas of twinkling lights, giving us the comforting illusion that the universe is a crowded, cozy neighborhood. But it isn't. The cosmos is a terrifyingly empty desert, and the few things that do exist within it are so staggeringly far apart that they are, by the very laws of physics, permanently isolated from one another. Let's step outside our door. When we think of our solar system, we usually picture the classic school textbook diagram, the sun in the center, with the planets neatly lined up like marbles on a desk. It makes space look manageable. It's a lie. In 2006, NASA launched the New Horizons spacecraft. It was the fastest object ever recorded leaving Earth's orbit, screaming through space at over 36,000 miles per hour. It took 9 full years of continuous, high-speed travel just to reach Pluto. 9 years, just to get to the edge of what we considered our immediate backyard. But Pluto isn't the edge. It's barely the front porch. Beyond Pluto lies the Oort cloud, a colossal, spherical shell of billions of icy remnants left over from the birth of our system. This cloud extends up to 1 full light year away from the sun. To this day, humanity has never directly seen it. It is too dark, too cold, and too distant. Consider Voyager 1. Launched in 1977, it has been hurtling away from us for nearly half a century. It is currently over 14 billion miles away, making it the most distant human-made object in history. Yet, at its current blinding speed, Voyager 1 will need another 300 years just to reach the inner edge of the Oort cloud, and to finally pass through it and exit our solar system completely. 30,000 years. 30,000 years of continuous flight, just to leave the gravity of our own home star. Once you cross that threshold, you enter interstellar space, the deep, frozen ocean between the islands. The closest neighboring star system to us is Alpha Centauri, a trio of stars anchored by a small, red dwarf called Proxima Centauri. It sits roughly 4.2 light-years away. Think about that term. A light-year isn't a measurement of time, it's a measurement of distance. It is the distance that a particle of light, the fastest moving thing allowed to exist in our universe, can travel in a single Earth year. Light travels at 186,000 miles per second. It can circle the entire Earth 7 times, in the blink of an eye. Yet, even at that absolute cosmic speed limit, a beam of light leaving Earth today will take more than 4 years to reach our nearest neighbor. If humanity attempted to send our best current spacecraft there today, the journey wouldn't take lifetimes. It would take civilizations. It would take roughly 70,000 years to arrive. If our ancient ancestors had boarded a ship when they first walked out of Africa, they would only just be arriving at Proxima Centauri today. Scientists have proposed radical ideas, like Breakthrough Starshot, a plan to use powerful, ground-based lasers to push ultralight nanosons to 20% the speed of light. That would get them there in about 20 years. But there's a catch. These probes would have no way to slow down. They would screen through the Proxima Centauri system in a matter of seconds, snap a few blurry photos, and disappear forever into the dark. A fleeting glimpse of a neighbor we can look at, but never visit, is Proxima Centauri b, a planet sitting right in the star's habitable zone where liquid water could theoretically exist. But because Proxima Centauri is an unstable red dwarf, it regularly unleashes violent, radioactive flares that strip away atmospheres and bake the surface in deadly radiation. The closest planet to Earth capable of holding life might not be a second home. It is likely an irradiated corpse. As we widen our lens to the scale of our entire galaxy, the Milky Way, the numbers stop making sense altogether. Our galaxy is a swirling disk of up to 400 billion stars. It is roughly 100,000 to 200,000 light-years across. If you wanted to cross from one side to the other at the speed of light, you would need to survive longer than modern Homo sapiens have existed on Earth. At the very heart of this cosmic structure sits Sagittarius A star, a supermassive black hole with a crushing mass of 4 million of our suns. It dictates the orbital dance of everything around it. Yet, despite housing hundreds of billions of stars, the galaxy is mostly nothing. On average, stars in our region of the Milky Way are separated by about 5 light-years. To understand how empty that is, imagine shrinking our sun down to the size of a tiny grain of sand. To keep the scale accurate, the next nearest grain of sand, Proxima Centauri, would have to be placed 20 miles away. This extreme emptiness creates strange paradoxes. In about 4 billion years, our galaxy is on a collision course with our neighbor, the Andromeda Galaxy. Two colossal structures containing over 1 trillion stars combined will slam into each other. You might expect a cosmic apocalypse of colliding planets and exploding suns. But astronomers know the truth. Because the gaps between stars are so profoundly vast, the probability of even 2 single stars physically colliding during this merger is practically zero. The galaxies will simply pass through each other, like 2 ghosts dancing in the night, their gravitational fields pulling at one another, reshaping the sky, but never truly touching. When we look across the intergalactic gulfs to other galaxies, we aren't just looking through space. We are looking backward through time. Because light travels at a fixed speed, it acts as a cosmic time delay. The further out we look, the older the universe becomes. Take the Andromeda Galaxy, our nearest massive galactic neighbor. On a clear night, far from city lights, you can see it with your naked eye as a faint, blurry smudge in the sky. It looks peaceful. But the light hitting your retina at this very second left Andromeda 2.5 million years ago. Think about what Earth looked like when that light began its journey. Modern humans did not exist. Our distant ancestors, Homo habilis, were just starting to shape the very first crude stone tools in Africa. That light has traveled across an unfathomable void for millions of years, carrying an image of Andromeda from the deep past. If that galaxy had exploded or vanished yesterday, we wouldn't know it for another 2.5 million years. If you could pull back far enough, millions of light-years away from Earth, the universe would suddenly reveal its true shape. It looks exactly like a colossal, glowing neural network. We call this the cosmic web. This structure is made of long, thin filaments of hydrogen gas and dark matter, along which trillions of galaxies cling like dewdrops on a spider's web. These filaments actually originated from tiny quantum fluctuations at the very beginning of time, stretched out across billions of light-years by the rapid expansion of the Big Bang. But where there is a web, there are also gaps. And the gaps are the most haunting places in existence. Behold the Boötes Void. Discovered in 1981, this is a region of space so unimaginably empty that it defies comprehension. It spans roughly 330 million light-years across. Based on the average density of the universe, a region of this size should contain at least 10,000 healthy galaxies. It contains fewer than 60. If you were inside a spacecraft in the center of the Boötes Void, you would look out into the night in every direction and see nothing but total, ink-black emptiness. No stars, no galaxies. Just an endless, silent sea of nothing. As we approach the limits of what we can map, we find structures that seem to break our very understanding of physics. In 2014, scientists mapped the movement of thousands of local galaxies and discovered we belong to a cosmic supercluster named Laniakea, a Hawaiian word meaning immeasurable heaven. Spanning 520 million light-years, it resembles a cosmic feather, with every galaxy flowing along gravitational rivers toward a mysterious, invisible gravity well called the Great Attractor. Yet Laniakea is completely dwarfed by the Hercules Corona Borealis Great Wall. This is a massive sheet of galaxies bound by gravity that stretches up to 10 billion light-years in length. It is so astronomically vast that it takes up more than 10% of the entire observable universe. In fact, its existence actively troubles cosmologists. According to the standard model of physics, the universe should be relatively uniform on its largest scales. A structure 10 billion light-years long simply shouldn't have had enough time to form since the Big Bang.
Our telescopes, like the James Webb, can peer back over 13 billion light-years, catching the ghostly light of the very first galaxies forming just after the dawn of time. Beyond that lies the cosmic microwave background, a wall of radiation marking the absolute visual limit of what human eyes can ever see. But our view is shrinking. We live in a universe that is not just expanding, but accelerating in its expansion, driven by a mysterious force we call dark energy. Because of this acceleration, there is a boundary called the cosmic event horizon, sitting roughly 16 billion light-years away. Any galaxy currently beyond this horizon is moving away from us faster than the speed of light. The light leaving those galaxies today will never reach Earth. If we boarded a spaceship moving at light speed right now, we could never catch them. They are permanently cut off from us. Every single second, thousands of stars and entire galaxies are crossing this horizon. They are slipping over the edge of our observable universe, falling out of our reality, forever. In the far, distant future, the expansion will have pushed all other galactic clusters so far away that the night sky over Earth will be completely dark. Future civilizations will look out with telescopes and see absolutely nothing but their own home galaxy. They will have no way of knowing that other galaxies ever existed or that a Big Bang ever occurred. They will believe they are entirely alone in an infinite, dead void. We happen to live in a brief, cosmic window where the universe is still visible. We can see the stars, we can map the web, we can look at our neighbors. But the clock is ticking, the expansion is accelerating, and the cosmic doors are slowly, irreversibly closing.